Assalamu alaikum. My name is Dr. Saqib Iqbal and welcome to lecture number 6 of software construction. Today we'll talk about Java implementation of the classes we studied in the last lecture. So before going on to the implementation of these classes, I would like to give you a recap of the concepts we studied in the last lecture. First we studied class, a normal class, and as you know that class is the set of objects, the related objects which have got shared behavior and shared states. And then we saw a couple of more types of classes like interfaces and abstract classes. So abstract classes are basically the classes which you make to look at the overview of the system. Once you implement the classes, you have to put all the implementation in it, including its methods, its attributes, and all the related instance variables and class variables. And once you have got this much detail, you cannot look at the overall picture of the system. So it's always recommended that when you are discussing the system with the clients, or when you are looking at the design of the system, or when you are trying to come up with any changes in the system, then you should make the system as simple as possible. And to make that, you have to make abstract classes. Now abstract classes, how they are different from normal classes? Well, they have got nothing in their body. So they've just got a name, and then there are methods which doesn't have any implementation. Similarly, they can have attributes and data sets, but those cannot be initialized and you cannot assign any values to them. Similarly, you have got interfaces. Now interfaces are made when you are trying to make a template for classes. For example, you have got a type of classes and you want to make a generalized form of those classes. So you make an interface and you put all the related methods which are essential for that interface within the body of the interface. And then whatever class implements that interface, that class has to implement all the methods and the data variables which are part of that interface. What is the benefit of interface is that for example, if you are making a system and you want to implement particular kind of methods in all kind of classes that are going to implement that, then you should start with interface. The interface can have as many methods as you want, and all those methods has to be implemented within normal classes. So moving on today's lecture, the agenda, the topics which we are going to cover in this lectures are interfaces in Java, reference data types, abstraction classes in Java, and overview of the generics in Java. The reading is the Java tutorial which I told you in the previous lectures, and you can also find a lot of material on internet, and if you consult any object-oriented book, you can find loads of stuff about Java and all its concepts and constructs. And the reading also includes what is an interface. Now I will also recommend, if you are consulting a book, there is always a lot of material about interfaces in every book. But you can go online and there are so many tutorials available. You can even check Wikipedia for interfaces and Java concepts. And then inheritance is also as important, because without inheritance you cannot implement polymorphism, as we discussed in previous lectures. And interfaces and inheritance are very essential concepts in object-oriented programming. So whenever you are going to implement a system in object-oriented programming, these are the two patterns which you have to follow if you are making a true object-oriented system. Then why use generics? We're gonna study about them in a little bit later, but you should also study about generics, and you can find a lot of stuff about generics in Java tutorial or online in any tutorial which is available about object-oriented programming. Okay, so what is the objective of this course? The topics which we are going to cover is that after you have studied this lecture, you will be able to understand and use interfaces, and also the reference data types. Now the data types, as you might have studied Like there are data types like integer, floats, doubles, which you are used to initiate, or which you are used to declare attributes of the system. Same types of data types are used for interfaces as well, and they're called reference. Like interface can be used as a data type, and you can call it a reference data type, and that reference data type will implement all the methods which are in interfaces, and you can also implement all the classes which are implementing that particular interface. Now abstract classes, again, as we have studied before about them, now we are going to look at their implementation. So in this, after this lecture is finished, you'll be able to declare abstract classes, you'll be able to extend abstract classes, and to use inheritance with abstract classes. And then I'm going to give you the introduction to generics. Now generics are some of the concepts which are general to all object-oriented constructs. This lecture will also give you the basic theory, but they won't give you a working understanding. You have to do the hard yards of putting these ideas into practice yourself. You won't even understand the theory if you listen passively to lectures, and I will try to help you learn how to learn from the Java tutorials. And you will get many chances to develop an understanding in the lab assignments, which we are going to give you a little later. Okay, the interfaces. Let's have a recap of the interfaces. If you look at this diagram which is given in this slide, now this is an interface which is named person, and it has got three methods: get name, get email address, and secure login. Now there are two classes, lecturer and students, that are implementing this interface. Now these two classes will have to implement get name, get email address, and secure login, because interfaces are also called public contracts. Now if you have studied in the previous lecture, I told you that these are also called contracts because they are kind of agreed upon documents which are between clients, customer, users, and the developers. So it's a kind of a contract which has been discussed or which has been agreed upon by both the parties, like by the party who has assigned you to develop the system and you as a developer. So now if this is an agreed upon contract, then you have to implement all the methods which it has got. So interfaces are drawn like classes, as you can see in this diagram, but without attributes and with the keyword interface. So interface is a keyword used here, and you don't use it with classes, mind you, but you should use it with interface to distinguish it from the classes. Otherwise they will just look like classes. And if you look at the arrows which are being extended from lecturer and student classes, they are dotted arrows, and they have got open-ended, and they are directed to interface, which means that these two classes are implementing this particular interface, and these two classes does not have any methods in them. Why don't you put in any methods? Well, you can always include any methods which you want to add other than the methods which are in the interface body, but you have to implement these methods as I told you before. So in addition to that, it's up to you. If the system wants you to add some new methods, you can totally do that. And we also say that class fulfills the contract specified by this interface, or that it realizes the interface. Now the realization in software engineering is that if you add this kind of arrow, which is dotted arrow, to any two different constructs, then it means that one construct is realizing the other construct, which actually means that it is taking its behavior in itself and it's trying to implement that behavior. So the realization is used in many different kind of diagrams in software design. For example, you must have noticed in control flow diagrams, whenever you want to show a control going from one construct to another one, then you show it with dotted lines. And you should also note that interfaces define methods but not attributes. Now why the attributes are not added in the interface? Because interface is a contract, and there are only methods included in them which you want to implement in the classes which are going to implement this particular interface. Now attributes could be their own, like the classes student here and the lecturer, they can have their own attributes, but they are going to have these certain methods. Now if you look at this, this is also an example of inheritance. Now inheritance, you can say that both student and lecturer are type of person. So these are the methods which they should implement, and they can have additional methods, of course. Now you must be wondering then, what is the difference between interface and inheritance? Now the difference is very slight, and it is very subtle. It depends only on the development, the kind of development you want to adopt. Like there are many methods and techniques which you adopt while you are developing a system. So it totally depends on the situation or on the demand of the clients or the kind of a system you are going to develop. In this particular example, what you want to do is that you want to have a general class which is called person. Then you are going to add a lot of other classes which resemble with person class, but they can have their own attributes, they can have their own additional methods. As I told you before, it's a kind of contract as well. If you look at inherited class, that's not a contract. That is totally on your usage. For example, if you want to add reusability in your system is too complex, or it is distributed and it is going to have a lot of code in it, then you want to add inheritance in it to avoid some lines of codes. If you remember inheritance, what you have to do is, like if you have put some methods in the parent class, you don't need to declare them in the child class. So you can simply reuse the methods which are in the parent class. And of course you can add some behavior to it. Of course the children always have some additional behavior of their own, but you can take the exact code from your parent class and you can use in the child class. And so this way actually you are reducing the number of lines, you're reducing the code, and you're enhancing the reusability, because the code is only defined in the parent class. And all the child class and the children classes could be as many as n number. I mean, it's totally up to the usage or up to the development style, that as many children you can have. And all those children can take the methods from parent classes. They don't have to rewrite them. So this is the biggest difference, that the usage or the kind of system you are going to develop. If the system is very small, you don't need to reduce the number of lines, so you can go with interface. But if there is a system where you want to save memory, or if you want to increase the reusability of the system, then I would recommend inheritance. Okay, interfaces in Java, they are just like classes with no bodies in the methods. It may define constants, public, static, and final, but no runtime variables. Now interface, as I told you before, they don't have attributes, but if you want to add some constants which are just like attributes, then you will have to use these three types with them, like public, static, and final. But mind you that they cannot have runtime variables. So what does that mean? Because the runtime variables, which are also called dynamic variable, they can only have values when the system is executing. Now you cannot assign them values before that, or you cannot assign them statically in the body of the code. Now interfaces cannot have runtime variables just because they are not actual classes. Okay, so they are just the contracts. So they are not going to have an implementation. You cannot declare an object, or you cannot instantiate any instance of an interface. So there is no point of having attributes in the interface. Interface acts just like a template for all other classes that are going to implement it. So usually an interface is public. So you can have it private, but that doesn't make any sense, because you are going to have a lot of classes which will implement this interface. So having it private doesn't make any sense, that if it is private then no other class will be able to access it. So you should always keep it as public, and even if you don't declare this, then Java compiler automatically assigns public to it. An interface provides a standard way to access a class, which could be implemented in many different ways. Now the Java tutorial, so in the Java tutorial there are a number of situations in software engineering when it is important for desperate groups of programmers to agree for a contract that spells out how their system will interact. Now each group should be able to write their code without any knowledge of how the other group's code is written. Generally speaking, interfaces are such contracts. So as I told you before, if the designers are going to discuss it with the programmers, then they both can agree upon some methods in an interface. Now it's totally up to them how they are going to implement them, like what kind of code they want to write about them. If you want to look at the example from the real world of an interface, then I would say a simple car is an interface. And if there are multiple cars, if there is a car manufacturing factory, and if they are making different types of cars, then a car is an interface, and then you can make different kind of cars from it, like you can have a racing car from it, or you can have a turbo car from it, or you can have different types of cars. So those cars going to have methods which are same to each other. For example, there should be a method of changing gears, there should be a method of having a turbo system. You can have a manual system as well, or there is a clutch system in as well. So you are going to implement all these methods. Now the interface of the car can have these methods as contracts. For example, there is going to be a method for air conditioning, or there is going to be a method for a heater that is for that car. Now that methods are not going to have implementation, because different cars are going to implement these methods differently. So in the interface you only declare those methods which are shared by all the other classes. That's why they are called contracts. So in implementation in Java, a class which implements an interface must provide an implementation of every method. A class may implement some additional method, as I told you before, but you should always be careful that adding another method to an existing interface will break every current implementation of the interface. Now you should not add, during the runtime, you should not add any other method in the existing interface. So why you should take care of this thing? Because if you have declared classes which are going to have all the methods in the interface, and then suddenly you want to add another method to the interface, then what it will do is that the system will not remain constant, because that additional method will not be reflected in all the implementing classes, because implemented classes have only those methods which were declared previously in the interface. So you should be careful that you should not make any changes to the interface after the classes, implementing classes, have been declared. Or if you want to add a new method, then you should add it to all the implementing classes as well. Then it will keep the consistency in the system. A class can implement many interfaces. An interface can extend other interfaces as well. I'll show you some of the examples in the later slides. Extension is the preferred way to add new methods to an interface. And why extension? Now, extension is basically inheritance. So when you are adding an inheritance, then it means that the implementing classes are not only going to have an interface, but they are going to have a parent class as well. So in that way it becomes easier to add any new method to an interface through inheritance. I'll show you some example and then you will understand this concept better. In Java, classes are less extensible than interfaces, because a class can extend most one other class, so single inheritance. I think you have studied this, that there are multiple inheritances, but they are on a different level. Like a child class can have grandfathers as well. Okay, they can have father and they can have grandfather, but you cannot have multiple inheritance on single class. Okay, so a single class can have only one parent. But if you look at interfaces, a class can have multiple interfaces. So this is another advantage or another difference between interfaces and inheritance. Now if you look at this class, and this class is an interface, and its name is bicycle. Now it has got some methods like change cadence, change gear, and speed up and apply brakes. Now these are the methods which are going to be in all kind of bicycles. Now if you look at this class, this is a typical type of a particular type of bicycle, and what it is doing is it is implementing bicycle. Now if you look at this, because it's implementing this interface, now it has to implement these four methods, sorry. So the implementation of these methods are going to be in the implementing class. Now if you look at the example of this interface implementation, there are methods but there is no implementation added to it. But in the implementing class, you are actually adding implementation to these methods. But there is also another thing to notice, that not a single method is missing from the implementing class. All the methods are being implemented in it. Okay, similarly, this is an implementation usually has variables. Now I told you that you should not add variables in the interfaces, but you can have variables in the implementing class. It's up to the implementation, the kind of implementation you are going to have. And an implementation may be incorrect if you are going to have an object of the interface. Now I told you you cannot declare any instantiation, or you cannot declare an object of interface, so you should avoid that. Okay, if we look at another example, now this example, there is an interface named group interface, and it is actually extending 3 other interfaces. Now you can declare multiple interfaces as well, and you can have inheritance in the interfaces as well. Now in the body of this, you have got base of natural logarithms, and you have got double E. Now double E, basically this is a constant. This is not a variable, and this is not a particular example of a dynamic variable. This is a constant one because it has got a particular value in it. And why we declare it in interface, it is usually recommended you should not have any variable, but you can always have final, static and public variables, and those variables are going to have particular values. For example, if you are going to make an interface for solving mathematical equations, then you can always declare the value of pi in the interface. So this is similar to that kind of example. You have got E, and E has got a particular value. Now this E can be used in the implementing classes, or it can also be used in the child interfaces. Now if this interface is acting as a child, then it can only give these values or this particular value to its implementing classes only. Okay, these are the method signatures: void do something, and it has got these 2 variables. And there is another one, integer do something else, string s. Now this integer of course is the return type, and there is no return type with the first one. That's why you have got void there. And in example 3, there is an interface event listener. Now if you have used graphics, and if you have developed a system which has got graphics in it, then you must have used mouse listeners or keyboard listeners, or you can have listeners for any device which is connected with the system. Now what these listeners do is that these listeners wait for any input from the devices, and once the input comes, then they take the action which is declared in the body of the listener. So if you look at this event listener, the event listener is for any type of event which is going to happen in the system. That could be an input from the mouse or input from keyboard, or it could be input from any external system which is connected with this particular system. So you have declared this event listener, you have not added any method signature, you have not added any constants. A tagging interface that all event listener interfaces must extend. If you read this data, it is available on the internet, then you will find out that there is a tagging interface which is included with all kind of interfaces. Now why? At first glance that is worse than useless. One more name for the Java programmer to remember is that this tagging interface. Now tagging interface, sometimes some compilers add it by default, so you don't have to declare it in the beginning. But you can always declare event listener, and sometimes it is suggested that if you don't declare it, it has already got its declaration in the library which is connected with the compiler. Okay, this interface allows programmers and the Java compiler to distinguish event listeners from all other types of classes and interfaces. Event listeners are important as they behave quite differently to a regular class. Okay, why? Because if you look at this example, this is the implementation of event listener. What happening here is that you have got MouseListener interface which is extending event listener. Okay, remember that if an interface is extending some other class, so that interface does not have to implement any method, because if you look at the inheritance rules, then you know that this interface is going to take all the methods from the parent class. Now this particular interface is extending event listener. It means that whatever the methods are there in the event listener, this interface is gonna have them. Now even if there is no declaration of these methods in this particular interface, even then the implementing classes will have to implement all those methods which are the event listener, because event listener is the parent class. Okay, now this is a bit confusing because in the implementing class you only add those methods which are part of the interface, but here in this case you don't have any methods in the interface, but actually that interface is extending event listener. So all those methods which are in the event listener are automatically added to this interface. Okay, so the child classes will have to implement them. So all known sub interfaces are in the mouse input listener. Now this is the mouse listener, and there is a mouse input listener which is the sub interface of it, and there are other interfaces included in it as well. All known implementing classes. Now if you look at these are the implementing classes which actually implement this mouse listener. There is AWT event, multicaster, there is basic button listener, there is basic combo pop-up, there is invocation mouse handler, and basic combo pop-up. We don't have to go into the details of this, but all these listeners and all these classes are used in the graphics. List mouse handler, basic desktop icon, user interface, and mouse input handler. Now if you want to read more about this stuff, you can simply Google them and you will find a lot of material about them, or if you go on the Java tutorial, there is explanation about every class, and there is also the declaration of methods and all the attributes which are included in this class. The whole body is given there, so you can find more stuff about it if you're interested. Okay, so this is the interface of the mouse listener. Okay, and it is extending event listener. Now these are the methods which this interface has got, mouse clicked, mouse entered, mouse exited, mouse pressed, and mouse released. Now these are the basic features of the mouse. The mouse listener, what it is going to do is that if there is any event or if there is any action out of these methods, then this mouse listener will take action accordingly. For example, if there is a mouse clicked, or if mouse is entered, or if the mouse is exited, or if it is pressed in any way, like it has got two options to press, left and right, or if any of those options is pressed, then it's gonna send a signal to the mouse listener, and then appropriate type of action will be taken accordingly. And there is a mouse released as well. Sometimes you have to keep pressing the mouse, and there is a different action for that, and when you release it, then there is a different type of action. So all these actions are defined, or they will be defined, in the implementing classes, but you can also define them in the event listener, or in this any type of class which is implementing this particular interface. Again, there is another one, interface mouse motion listener, and it has got two methods. One is mouse dragged and one is mouse moved. So when mouse is moved, then a different kind of actions could be taken, and if it is dragged, then there are different actions. Now how you are going to define them, if you look at the argument type, there is mouse event, E. Now E is the object of the mouse event, and this E can have multiple methods which are declared in the libraries. Okay, so you don't have to worry about those methods. If you want to know more about them, you can read those libraries, but there are new Java editors or IDEs available nowadays that if you want to use this object, they will automatically show you the methods which are attached to this object. If you ever happen to work on JBuilder, or there is Eclipse as well, I told you about Eclipse in the last lecture. So if you use that IDE in the Eclipse, then you have to declare this body, and then whenever you want to use E, you simply write E dot, and it will show you the list of all the methods which are attached with mouse events. Okay, so you don't have to memorize them, because there is a long list of methods which are attached to this particular interface. Okay, and there is another interface, mouse input listener. Okay, that was mouse motion listener, but this one is input listener, which is extending mouse listener and mouse motion listener. So again, there is a kind of inheritance in the interface which you can use. Okay, I would recommend you to implement this code in Eclipse IDE or any type of IDE which you have got, and try to run it and try to see what it does. What you can do is that you can have some implementing classes for these interfaces, and then you can use these objects and try to look what kind of different methods are available, and try to use them, try to play with them. In that way you will have better understanding of these methods and their usage. Okay, now this is the design of the interfaces which we just talked about. Now if you look at this, this is package diagram. I showed you before in the previous lectures that packages are basically the sets of the classes which are related to each other, and you can also mention interfaces on all the implementing classes in the packages. Now I told you before, the package is a rectangular box which has got a top rectangle on top of it as a sign that it is a package, and of course you have to distinguish it from classes diagram, so this is a different kind of notation for it. And this is another one, another package. Now in this package you have got mouse motion listener interface, and it has got two children interfaces like a mouse listener and mouse input listener. And similarly, these two are extending this interface, which is event listener. Now event listener is the parent of these two interfaces, and this interface is the parent of these two specialized interfaces, And there is one class which is actually realizing this particular interface, which is mouse input listener. Now what is this class doing here? It is a drawing area. So if you are going to draw something, okay, if you are going to develop a system which in which you can draw some diagrams, or you can draw some pictures, then you can use mouse motion with it. If you ever worked on MS Paint, then you must have seen that all the painting which you do in MS Paint is with the help of mouse. So it has got different kind of actions which you can take, different kind of drawings you can make, but all of them are with the help of mouse. So similar, if you are going to develop a similar kind of system, then there is a drawing area class which you will have to implement, and that drawing area is actually realizing mouse input listener. So whenever there will be any input from mouse, this drawing area class will have particular methods which are part of this interface, and that methods have got implementation of that motion of the mouse. Okay, so whatever the motion that mouse is doing, then accordingly you are going to take action within this class. Okay, using an interface as a type. Now this is an advanced kind of functionality of an interface, that you can use it as a type as well. Now this might be a little bit difficult for you to understand, but if you look at it this way, like whenever you make a type of an attribute, what you do is that you give it a data type. There are different kind of data types like float, double, long, integer, short, or if you are going to have a string type, then you have got character and string data types. Similarly, you can make data types of interfaces as well. So what you do is you simply write the name of an interface in the place of a data type, and then you can declare any variable with it. So that variable will act as that interface. Okay, that variable will have all the functionalities which are part of that interface, and you will use it as a data type in different kind of situations. I'll show you examples a little later. Okay, when you define a new interface, you're defining a new reference data type. Now why we call it a reference? Because that data type is a reference to that particular type of interface. You can use interface names anywhere. You can use any other data type's name. If you define a reference variable whose type is an interface, any object you assign to it must be an instance of a class that implements the interface. Now this is very important, because if you are using an interface as a data type, then you can only use it within a class that is implementing that interface, because interface is only interacting with its implementing classes. Okay, so you cannot use that data type in any other interface or in any other class that is not part of this interface. Okay, because it's a kind of a contract. Okay, we also call it a public contract. So if you go out of the contract, it means that you are violating that contract, and you are using the interface in such a situation where it is not supposed to be. Okay, and if you want to read about the usage of the data type or the usage of interface as a data type, then you can go on this Java tutorial and you can find these links there, and it has got all the explanation about the usage of this particular kind of data type. A method for finding the largest object in a pair of objects for any objects that are instantiated from a class that implements relatable. Now if you have got this interface which is called relatable, and it has got a method is larger than. So what you are going to do is that you're trying to find larger variable out of two variables. Okay, so if you have got two variables, you want to find out which is the larger between these two. So what you can do is you can make an interface relatable, and you can have a method is larger than within that relatable method. And then what we are going to do is that we have got this one method which is find max. Now find max will find the maximum between these two objects. So what it is doing is that it is using that interface as a data type. If you look at that, that is the interface relatable, and you are declaring this object as relatable. Okay, so what you're doing here is that you are making a type of relatable, and then you are assigning the object one which has been passed on to this method. You're assigning that object to this relatable object. Okay, but of course you will have to typecast it first. Now this object one is object type, but when you are going to assign it to a relatable type, then you will have to typecast it to a relatable variable. So this process is called typecasting. If you have not studied it before, I would recommend you to Google it, like what is typecasting. And typecasting could be done with any type of data types. That if you are going to assign an integer to a float type, then you can simply write it within parentheses. Like if you want to convert a float, then you will write in the parentheses float, and the integer will automatically convert it into a float type, and then you will be able to assign it to a float variable. So the same kind of thing we are implementing here, that we are typecasting object 1 and object 2, and we are assigning them to other variables, object 1 and object 2, which are of type relatable. Now once they are relatable, then you can call this method is larger than. Now this is larger than is basically a part of this interface. Now is larger than is a part of this interface, so it is also part of the implementing class. Now this method is in that implementing class. So what you are going to do is that you are calling that method which has been implemented in the implementing class, and that method name is larger than, and you are calling it through this relatable object 1. Okay, now once you call it, then you can assign a logical operand here which is greater than, and then if it is greater than, then it will be returned. If it's not, then the object 2 will be returned. Okay, so if comparisons are important in your application, then you will be able to write very elegant code if you're using it this way, if you're using interface as data types. You can write z.find max as well if x and y are instance of any class which extends relatable. So it's not only about any class that implements relatable, but it is also if it is extending relatable. Okay, but there are some dangers of using interfaces as a type as well, or those dangers are that you can mismatch two different types, and if you are mismatching them, then it will obviously give you a compile time error. Because how you can mismatch it, I'll show you an example. Now that is the code which we wrote in the previous example. Now you can get a compile time error if object 1 dot is larger than object 2 were in the body of this method. Because if you put it in the body of this method, then basically if this method is not part of that class which is implementing the interface, then of course there is going to be a compiler error, because compiler won't be able to understand that what kind of relationship you are going to implement here. Because if the class is not implementing the interface, then the method is not there, and the compiler will throw an exception. So what you can do is, to avoid this kind of exception, you can have exception handler in your code. Okay, I'll show you that example of exceptional handler in the next slide. Okay, and we invoked it as x.find largest if y dot is larger than does not accept z as a parameter. So if there is any kind of data type mismatching in the arguments or in the parameters, then of course you are going to have a compiler time error. If it is easy for a programmer and a compiler to determine the class of all arguments in every method call, then you can avoid these dangers. How you can do is, okay, this is okay, before going on to the example of handling these exceptions, if you look at the type rules, now we have got this diagram in which we have got interface I1, and it has got two methods, M1 and M2. There is a class C1 that is implementing I1. So this is the code for writing an interface. If you are going to implement an interface, you will add this keyword to the implementing class. This keyword is implements. You should know the difference between implements keywords and extends keyword. Extends is used for inheritance and implements is used for interfaces. Yeah. Okay, so you've got these two methods, M1 and M2. If you look at it, you don't have any implementation of these methods there. But if you look at here, you have got these curly brackets which show you that you're going to implement these two methods in this class. Similarly, this interface I2 is extending I1. It means that this is a child interface of this I1, and there is a class C2 that is extending, that is implementing this I2. So you can look at this, that there is a realization stereotypes here, there is a realization arrows here. So this is how you show them in the design. But how you use them is that you have got C1A. Okay, A is a reference variable of type C1, and you have got B, which is again a reference variable of C1. Here you have got P, which is a reference variable of type I1. Now what is I1? I1 is the interface. Remember, you can use interface as a data type. So here is an example of that usage, like I1 is being used as a data type here. And then what you are doing here is that the P is interface I1 type and P is calling M1. Now how can P call M1? Now P is an interface. Interface cannot call any method because it cannot implement any method. So, but if you use them as a data type, then you can always call the methods. So this is another way of calling interfaces methods. I told you before in the beginning of this lecture that you should not make an object of an interface and you should not call any methods of an interface because they don't have any implementation. If you do that, you're gonna get compiler error. But here you can use it as a data type, and when you are using it as a data type, then you can simply call the methods because methods implementation is always there in the implementing class. So you are calling p.m1. Now m1 is implemented in the class c1 and it is also implemented in the c2, but c2 is not directly related to i1, so this m1 will be executed. In the second example, you have got c2c. Now we are going to make an object of c2 type, and you are making a data type of I2, and it has got a variable q, and q is a data type of I2. Now you can call m1 and m2 from q as well, because it's the same kind of concept here, that if you can call m1 from p, you can also call m1 and m2 from q as well, because q are a data type of I2. So this is how you can call methods of interfaces. Of course, you are not calling them directly. What you are doing is you are using interfaces as a data type, and then you are calling those methods which are actually implemented in their implementing classes. Okay, now there is another keyword, instance of. Why you use instance of? You can use this operator to test an object to see if it implements an interface before you invoke a method in this interface. Okay, this might improve readability and correctness, and this might also be a kind of a hacking in the system. Okay, we will discuss this later, but first I'm going to discuss readability and correctness. Where possible, you should extend classes and interface to obtain polymorphic behavior rather than making a runtime check. You must remember polymorphism, which we discussed in earlier lectures. Polymorphism is simply calling methods with different kind of arguments. So you can call similar kind of methods with different kind of parameters which you give them. For example, when you are initializing objects in the beginning, when you are making them and you initializing them, you assign them different values. Okay, so those values are only assigned to those particular objects. Other objects cannot view those values and they cannot use those values. They can only use the values which are assigned to class variables, if you remember from previous lectures. But in the polymorphism is that you are calling the same method from the same class with two different objects, but you are actually calling it with different values. So if you look at this example, the instance of the example, you are using that polymorphic behavior of the interface again. What you are doing here is that if you have got this logical operator here, if b instance of bounceable, then b dot hit wall, and wall a is basically the parameter, else throw new assertion error. So for example, if you are developing a game and in that game you are trying to listen to the behavior of the ball, okay, if there is a bouncing ball in the game, now whenever that ball is gonna touch the wall, then you are going to take a different action. Well, if you have ever played bouncing ball game, then you must have noticed that what you do is that basically the angle with which the angle at which that ball touches the wall, then the ball is reflected according to that angle. So you have to do the calculation of the angles there. So when you are implementing that kind of a game, then you can implement these kind of interfaces, and then you can find out that if the ball is hitting the wall using instance of. So this bounceable is an interface, and you are making an instance of bounceable here. So B is the instance. Now if there is a hit wall object implemented in the bounceable, then it will give you a true value. And if it is not, then of course you can throw an exception, and you can take the action accordingly, according to that exception which has been thrown. Okay, so a new exception is being thrown here, throw new assertion error, B. Okay, so the B has to be instance of bounceable. Similarly, we have got date, some date, a new date, and throw an exception if some date is not relatable. So what we are doing is that date instance of relatable. So this instance of will tell you if the date is instance of relatable. If it is not, then of course a new exception will be thrown, and you can handle it in the exception handler code. There is more explanation about this exception handling and about the instance of in this particular link. Okay, you can go online, and there is a lot of material available about exception handling or about instance of in this Java tutorial here. Okay, these tutorials are also available on the Oracle website. If you want to know more about them, there are guides available. So instance all, I would recommend you that whenever you are going to write interface code, you should always use instance of. Of course, this is going to add a number of lines to it, and if you are implementing a very complex system and you are avoiding a lot of lines of codes, then of course you can consider not using it. But if your code is not very complex, and if you can afford some more lines of code, then you should always go with this instance of thing, because whenever you're using it, you will always have to write this if thing, and you will also have to write else and throw new exception thing. And once you are doing this, then you will have to write the code for exception handling as well. And even in the complex and distributed system, it is recommended that you should use this instance of, because it can save you a lot of trouble when the system is executing. It can save the system from being crashed, or it can save a lot of exceptions being thrown during the execution of the program. So it is recommended that you should use instance of. And it also saves you from the complexity, from the reading complexity, because if you read here, it is written that it's going to improve the readability and it's going to improve the correctness. Of course, it's improving the correctness, it's bringing in the consistency in the code, because then you are not using any interface which is not declared before, or you're not using any implementing class which is not declared before. So it will keep the data consistent, but also it is bringing in the readability. Readability is very important for the documentation, as we discussed before, that if your system is going to be used for a longer period of time, and then for the maintenance purposes, there should be a proper documentation available for a system. So if the code is written in this way, then it will be easier for the people who will follow you and who will read your code. And if they want to make any kind of new changes in the code, then this instance of thing, or the way this code is written, will make it more readable, and the code will be easy to be modified. Okay, and this instance of can also save you a lot of trouble, as I told you before. Okay, then we have got abstract classes, but before going on to that, I think we should wrap up here, because we are going to start the next lecture from abstract classes. So we're going to conclude this lecture here, but before finishing it, I would like to recap what we studied today. So what we saw in the beginning is that I gave you a revision of these basic concepts of abstract classes, interface classes, and normal classes. And I also told you about inheritance and the interfaces. So first we discussed it on the design level. There are different kind of diagrams which you use for these three different constructs. And those diagrams are similar to each other, but they have got a slight different notation to keep them distinguished from each other. And what you do is basically the interface is written with its implementing classes with the realization constructs. And what you do is that you show only those methods in the interface which you are going to implement in its implementing classes. You can of course write additional methods in the implementing classes as well. And then we saw the inheritance. In the inheritance, what you do is that you write different methods in the child classes, because the methods which are in the parent classes, that are automatically going to be used by children classes, so you don't have to rewrite them. So it can improve the reusability this way, that you are not writing the same exact code again and again. But in the interfaces, what you do is that you are going to implement them. So only advantage you are going to have is that you are not going to write the name of those methods in the implementing classes. But of course, when those classes are going to be implemented, then those methods are going to have their own body or their own code in them. And then we look at some examples of interfaces, that how you write their code in Java. And we saw that in the interfaces you can write the keyword implements with the implementing classes, and you can extend interfaces as well. You can have multiple interfaces with one class, but you cannot have multiple parents with children class. You must remember that. And we also saw that extends keyword is used for inheritance and implements is used for interfaces. And we saw some examples of interfaces and inheritance, and we also saw that there are some keywords which you can use to improve the readability and correctness of the code. Instance of is one of those keywords, and we also saw that interface, you don't write data variables in the interface, you can only write static and final variables, or those variables whose value is not going to change during the execution of the system. But you can have variables in the implementing classes. Of course, this is not the case in inheritance. In inheritance, you can always have variables in the parent class, because parent class is a normal class anyway in inheritance. And in the end, we saw this keyword instance of, which you should always use, because if the data type which you are going to use in the system is not a data type of the interface in which you are writing this, then the compiler is always going to throw an exception. To avoid that exception, or to avoid your system being crashed, you should always use instance of. You can put it in if body, if and else body, and then you can write the code for the exception which it is expected to throw. So that is the end of our today's lecture. In the next lecture, we will discuss about abstract classes and their implementation in Java. तब तक के लिए इजाज़त दीजिए. अल्लाह हाफ़िज़.